Hello, Miss Walsh here. So today we are going to learn how to define the domain and range of functions, okay? So every function is defined for certain x values and for certain y values, okay? And the domain is the set of all the x values for which the function is defined, and the range are the y. And nice way that some students like to remember is alphabetical. So you've got your D before your R for the domain and range, for the X before the Y. Okay, so let's take a look. So we have here a parabola, and implicitly there's arrows here. And what we want to do when we define the domain is we're looking left and right. So all the x values, okay? Sometimes it's useful to think, will the function hit 100? Will the function hit negative 100? So we can see here that it's defined for 1, 1.7, 2.3, doesn't matter. The function will have a value at every single little point. So basically, this function is defined for all the x values. Be careful, we're not talking about the y's, we are talking about the left and right, the x values, okay? And so the way that we write it is we open up these brackets and we write x is such that x is an element, so there's this e here, of all real numbers. Okay, now this is formal. If you just on a test wrote this XER, that would be fine, okay? But right now, I do want to introduce you to things properly. Okay, so now let's see what's happening on the Y. So when you're looking on the Y, you're now kind of orienting yourself on the up and the down. So again, do your little 100 test. So will on the Y, will it hit 100? Yeah, it will. It keeps going, 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 going. What about in the negatives? No, right? So the smallest value that it hits on the Y's, as you can see, is -1. So what we say is we would say Y is such that Y must be greater or equal to -1. Otherwise, Y is defined for all the real numbers, okay? And real numbers means anything at all. So as long as it's greater than that, then we're fine. Okay, let's take a look at the second one. I do realize that there's no scale here. Let's just treat it as 1 unit each. So we have 1, 2, 3, 4, 5. So this point is 5. And then this will be 1, 2, 3, 4, 5, 6, 7. Okay. So let's take a look. So this function is defined on the x, anything from 0 to 5, okay? Now, we have to be very careful because you notice that 1 is an open circle, and that means that this function will come very, very, very infinitely close to 5, but at 5 it's actually not defined. That's what that open circle means. So we're going to put the x in the middle, and we're going to say that x must be greater or equal than 0. It's defined for 0, but it has to be less than 5. Otherwise, it's defined for all real numbers, okay? And then on the y, we're now looking up and down. So again, from 0 to 7. So we would say y is such that y has to be greater or equal than 0, but it has to be less than 7. Otherwise, it's defined for all the real numbers. Okay, the next one is a little bit tricky. This is something new for you guys. And this is a function called a rational function. And the equation of this function would be something like 1 over x minus 1. Okay, so what's happening here is that the function is approaching this value right here, but it never actually hits it. Now it looks like it does, but it just gets super, super, duper, 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 duper close to this line, to this invisible line, okay? And this line is called an asymptote. Okay, so an asymptote is an invisible line that the function approaches and gets super close to, but doesn't actually hit. You'll notice that there's also a horizontal asymptote as well, okay? The function is not defined at the point where the asymptotes occur, okay? So looking at this now, we see that the function will indefinitely keep going on the x. So yes, it will hit 100. And on the y, and on a negative 100, it will also do so. The only place where it doesn't exist is this asymptote. So what we say is we say x is such that as long as x is not equal to 1, yeah, it's not defined at this 1, it's all the real numbers. And then on the y, you're looking up and down, it'll hit plus 100. It'll hit negative 100. But as you can see, it will never, ever, ever hit this 0, right? The x-axis itself. Okay, and so we say y is such that as long as y isn't 0, then y is defined for all real numbers. Okay. So now let's try this with a word problem, okay? So we've got the weight of a radioactive material remaining after t years is given by this function right here. Okay, go ahead and graph it. Press pause and do go through that process of graphing it. I already did, just to speed up this podcast, yeah? And so when you hit graph, just to note again on that window, when you hit graph, plot, you may be stuck with a window. Just look, the y-intercept here is 11.7, yeah? 2 to the power of 0 is 1, so it's 11.7, and from there on, it goes down. And so you can, from there, you can say, okay, start somewhere a little bit left of the y-axis and then just keep it going, okay? And you can try auto scale as well. Don't panic, it's very much a practice thing, okay? So the weight of this radioactive material is obviously decreasing. So the first thing for us to do is just to draw the sketch. So the function will look something like this, okay? This right here is 11.7, okay? And this right here is time, and this is the weight with respect to time. Okay, the domain for this function, keeping in context the fact that it's after t years, is going to be t is such that t is greater or equal than 0, because we can't have negative time, okay? Otherwise, it's defined for anything, okay? And the range, we will never have a negative weight, and this function actually approaches 0, but the weight is decaying incredibly slowly. It's taking thousands, maybe millions of years, and so it's defined for a positive weight, okay? So for the range, we would say that W is such that W is greater than 0. Okay, this is an exponential function and it will never actually hit 0. That may be a bit confusing. Don't worry, you'll get used to it more. Okay, so that's the domain and range of that one. Okay, so now in the you can try, you've got 2 of them that are graphed. Okay, watch out for this one. Hint, hint, there's your asymptotes there. And then this one, just go ahead and grab your calculator, graph it, find the maximum, and you can state it from there on. Bye.